Testing. Okay, I see the little thing going so you can hear me. All right. We are going to do 6.1. Start in chapter 6. So let me get to my pencil. Okay. All right, so we are doing, we are doing 6.1, which is all about something called factoring. And factoring is basically taking something that is added or subtracted and turn it into a multiplication problem. Okay? Factoring is changing from adding and subtracting to multiplying. Okay? All right. Let's try to do some of that now. All right. Let me move this for a second here. I've got something going on here. Move that. If this can get closer, I can make sure you can hear me. All right. So let's look at something like this. 9z minus 18. This is two pieces that are being subtracted. We need to change it to a multiplication problem. And the way you do that, the first thing you always look is, you look for what's called GCF, greatest common factor. Or basically, is there anything I can take out? Meaning, I can divide out evenly. Looking at 9z and 18, do they have a multiple? Do they have something in common? Do they have a greatest common factor? Well, they do. It's 9. Meaning, I can take a 9 out, divide it out, and tell you what's left. So if I divide both pieces by 9, this 9 and this 9 become a 1. You're left with z minus 18 divided by 9 is 2. We're going backwards from the distributive property. Before, you were given something like this and you had to multiply. Now you're given the answer and you have to put it into the multiplication problem. Okay? So what if I had 7k plus 28? I always first say, what can I take out? Is there anything I can take out? Well, they both have a 7 in common. I could take a 7 out. What I mean by that is divide, and I can say what's left. 7k divided by 7 is k, and 28 divided by 7 is 4. So here is my answer. What if I had 56m plus 35p? What could I take out? Well, they both have a 7 in common. I could actually divide out a 7. When I divide 56m by 7, I get 8m. When I divide 35p by 7, I get 5p. And that's my answer. Now, what if I had 9x squared plus 12x cubed? What can I take out? Well, between 9 and 12, I can take a 3. And because they both have the same variables, what you do is you take the lowest exponent. So they both have x's, and the lowest exponent is a 2. So that's how much I can divide out. When they both have the same variable, you take the variable with the and then you take the lowest exponent represented. 9 divided by 3 is 3, and x squared divided by x squared is 1. It's gone. Plus 12 divided by 3 is 4, and x cubed divided by x squared, remember we subtract, so you're left with 1. And that is your answer. All right. Let's try some more. What if I had 32p to the fourth minus 24p to the third plus 40p to the fifth. All right, looking at all three, what can you take out? Well, between 32, 24, and 40, greatest common factor is 8. And do they all have p's? Yes, they do. What's the lowest exponent? A 3. So this is what I can divide out. 8p cubed, 8p cubed, and 8p cubed. All right, 32 divided by 8 is 4. And p to the fourth divided by p to the third, I subtract, and I'm left with 1. 24 divided by 8 is 3. P to the third divided by p to the third, it's all gone. So there's nothing, no p's left to put. Plus 40 divided by 8 is 5. And p to the third divided by p to the fifth divided by p to the third, I subtract, and I'm left with 2. And there's my answer. Now let's try another one. 3k to the fourth minus 15k to the seventh plus 24k to the ninth. What can I take out? Between 3, 15, and 24, I can divide out a 3. Now, do they all have a k? Yes, they do. And what's the lowest exponent? A 4. So that's what I can divide each piece by. All right, 3 divided by 3 is 1, and k to the fourth divided by k to the fourth is gone. You just have 1. Minus 15 divided by 3 is 5, and k to the seventh divided by k to the fourth, I would subtract, and I'm left with k to the third. Plus 24 divided by 3 is 8, and k to the ninth divided by k to the fourth, you subtract, and you get k to the fifth. And that's your answer. All right, take it a step further. What if I had something like this? X minus 5 times x plus 6 plus x minus 5 times 2x plus 5. This is still an addition problem. It's this, it's all of this, plus all of that. Now, if that's the case, look at the first set, look at the second set. Do they have anything in common? Is there anything that I can pull out? Is there anything that they have both? Well, they both have an x minus 5. So I can divide both sides by an x minus 5. Now, if I do that, what's left? X plus 6 plus 2x plus 5. Now, they do expect you to reduce in here, meaning it's separated by a plus, so that's not going to change anything. So I have 1x and 2x, which makes 3x, and I have 6 and 5, which makes 11. And that is your answer. All right, let's take it a step further. It can get even worse, or bigger, uglier, however you want to look at it. What if I had z squared times m plus n squared plus x squared times m plus n squared? Okay, all of this and all of this separated by a plus. So look at the first term, z squared times m plus n squared. Look at the second term, x squared times m plus n squared. Do they have anything in common? Well, they sure do. It's the m plus n, and the lowest exponent is the same, it's 2. So I can take out an m plus n squared and tell you what's left. Okay, that's gone. So I'm left with z squared plus x squared. And I'm done. I've turned something from that was being added into something that's being multiplied. All right, let's go even farther. What if we had P times R plus 2S squared minus Q times R plus 2S cubed? This minus this. What do they have in common? They each have an R plus 2S, and what's the lowest exponent? Squared. So I'm going to divide by R plus 2S squared, and then I have to say what's left. Those completely cancel out. Got a P. Minus. Now, the Q is there, but these don't cancel out. I have 3 on top and 2 on the bottom, so I'm left with 1. Now, they're not going to want you to leave it like this. They're going to want you to simplify inside. So you have R plus 2S squared, and we have to distribute. So we have P minus QR minus 2QS, because I'm distributing the negative Q. And now that's the answer. Okay. We still not muted. Okay. I'm always checking now because it seems like that happens all the time. All right. Now, so rules of factoring, and I'm going to be writing this over and over and over again, okay? The rules of factoring are GCF, or what can I take out? That's the first thing you do every time. Then you have to ask how many pieces. If there are 4 pieces, we do what's called group. If there are 3 pieces, then there's 2 different things we look for. And if there are 2 pieces, there's 2 different things we look for. We are going to work on this. We've already done this. We're now going to go to 4 pieces. 4 pieces meaning this: AX plus AY plus BX plus BY. 1, 2, 3, 4 pieces. The first thing you want to say is there anything I can take out? Do they all have A's? No. Do they all have X's? No. Do they all have Y's? No. Do they all have B's? No. So there's nothing I can take out. So what I'm going to do is I'm going to group the first 2 together and the second 2 together with this in between. Now, by doing that, I am just going to look at this and say, is there anything I can take out? Well, these 2 both have an A. So if I divide both pieces by A, I'm left with that, A times X plus Y. Plus, what do these have in common? Well, they both have a B. If I divide by B and I divide by B, I'm left with X plus Y. Now look at it. Do they have something in common? Remember, they're still being added. Do they have something in common? Yes, they do. They both have an X plus Y. Now, if I divide out the X plus Y, what am I left with? A plus B. And now I factored it. I turned something that was being added and or subtracted into something that is separated by multiplication. It's factored. All right, let's try another one. These are difficult, so let's try another one. All right, what if I had 6P minus 6Q plus RP minus RQ? All right, I'm going to group the first 2, group the second 2, and they're separated by addition. If they're separated by subtraction, we have to do something different, and I haven't got to that yet. So I'm just pointing out that they're separated by addition, so we're good. Now, looking at this, what can I divide out of each piece? A 6. If I divide out a 6, I'm left with P minus Q. plus, what can I divide out of this? An r. If I divide by r, I'm left with p minus q. Now, I'm still being separated by addition or subtraction. So looking at this, what do they have in common? What can I take out now? Well, they both have a p minus q. If I divide out that p minus q, what am I left with? 6 plus r. Now they're separated by multiplication, so you have your answer. All right, let's look at another one. Practice makes perfect, so let's look at another one. What if I had 3x minus 3y minus ax plus ay? Well, I have 4 pieces, so when I have 4 pieces, I have to group, but this time I'm separated by a subtraction sign. So we have to group this with the subtraction sign on the inside. Just kind of remember we have to do something a little different. Now just watch real careful. I still look at this and say, what can I take out? And in this case, I can take out a 3 here, and I'd be left with x minus y. What can I take out of here? Well, I'm going to be able to take out an a, but it's this. So what am I really taking out? A negative a, okay? It's like you group it with it and you take it out negative. So if that is with it and I'm taking out a negative, that's fine. Those negatives are already there and the a's cancel out, so I'm left with x. But here, the a's cancel out and I'm left with what kind of y? A negative y. Now, are these the same? Yes, they are. So what can I take out? X minus y, because we're still being separated by addition and or subtraction. So I take out an x minus y out of each one. And what am I left with? 3 minus a. And there's my answer. All right, let's try another one. Those ones are difficult. When you get the negative inside, it can be a little tricky. So xy minus 2y minus 4x plus 8. All right, I want to group, but I'm separated by a subtraction, so I'm going to group that one inside of it. And then I tell myself, looking at the first set, what can I take out? Well, it looks like I can take a y out. If I take a y out, I'm left with x minus 2. It is still minus here. What can I take out of here? Looks like a 4. But what I'm actually taking it out as a negative 4. So that's gone. I'm left with x. What's 8 divided by negative 4? Negative 2. Now, what do they have in common? X minus 2. And what's left? Y minus 4. All right? Now, they can be not nice. They can give you something, and these are really like puzzles. We have to treat them like puzzles. Okay, the harder they get, the more of a challenge or a puzzle it is. Now, we have 4 pieces. So we need to group. But this time, at least it's plus in the middle. So we don't have to do anything extra. But let's look at this. What can I take out of 6a and x and 12b and x? Well, I can take a 6 and an x out. This time there's more than one piece you can take out, which leaves me with a plus 2b. Plus, what can I take out of a and a 2b? Nothing. So when there's nothing to take out, it's a 1. because if I took out a 1 and I multiplied back, would I still be the same thing? You have to have the 1. So when there's nothing to take out, it's a 1. Now, we're still separated by addition. What do I see here that they have in common? Well, they both have an a plus 2b. So if I divide out an a plus 2b, I'm left with 6x plus 1. And there's my answer. Oh, excuse me. Excuse me. I'm going to let that go. Okay. All right. One last thing that they like to do is they like to put it in the wrong order. It's so not nice. Okay? They put it in the wrong order, meaning when you group it, it doesn't work. Okay? So let's look at something that they would do, like p squared q squared minus 10 minus 2q squared plus 5p squared. 4 pieces. Now, they're in the wrong order because if I group these two together, is there anything you can take out? No. Got a separation of a negative. If I group those two together, is there anything you can take out? No. So we have to play around, and we have to try to decide what things they want together. I'm going to guess p squared q squared minus 2q squared plus 5p squared minus 10. I'm going to try it that way. All I did was rearrange the order. Now, group, and let's see if this works. What can I take out of here? Q squared. They both have a q squared, which leaves me with p squared minus 2. Plus, what could I divide out of here? Well, at least a 5. If I take a 5 out, I'm left with p squared minus 2. So it worked. What do they have in common now? Because we're still separated by addition. What do they have in common? P squared minus 2. And what's left when we divide out p squared minus 2? Q squared plus 5. And that's my answer. All right. Give it a try. Remember, the first rule is always, what can I take out? And then the next rule is how many pieces. If there's 4, you group. And that's as far as we've gotten on that big old long list that I had before. Okay? All right. Have fun. And I'll see you later.